TAMUK. This is Tyler Fotis, Lawrence Johnson, and Jordan Dar. We are senior architectural engineering students at Texas A&M University in Kingsville. Today we would like to share our senior design experience with you. We built and designed an HVAC system on wheels, and this project is supported by Ashray College of Engineering at TAMUK. The main purpose of this project is to facilitate the education of future architectural engineering students. By building this, we implemented the things we've learned at TAMUK, and we give future students a hands-on experience to learn HVAC systems.
For this design, we left plenty of room for future expansion of the testing system. Down here we have plenty of room for a command board for the sensors that are going to be installed later on, and also if you wish to purchase a generator to power it outside of the classroom, we have plenty of room to store the generator to do that. The type of aluminum chosen was grade 6061 T9 aluminum alloy. This aluminum gave us the high strength we needed, the corrosion factor, and the lightweight to make it rollable. Bottom of the bench, there's 4 caster wheels. This will make it easier to get it around where we need it to go into classrooms and around campus. We have 2 levels and a wall that separates the duct, most of the duct work on the back from the front, and also a lot of the piping system on the bench.
Our system is a standard VAV system with the reheat coil, and it is meant to supply air to 2 zones. Our HVAC system has 4 different components, which is the supply air, the boiler in the hot water system, the chiller for the chilled water system, and the return ductwork. Right here you can see the cooling coil, fan, the VAV box, and the reheat coil system. Right here you can see that there are transparent boxes so that you can see into the cooling coil piping, and you can see the filter. Right here you can see the return air duct system. Air is fed in through here, and there's an exhaust damper for any exhaust air. Here's your return air damper, and here's your mixing chamber with an outdoor air damper feeding into the supply zone. Here you can see the chilled water system. Is fed in through these pipes right here, running up into the cooling coil. And right here you can see the expansion tank that is included with the boiler. And here's the piping running up through the reheat coils for the VAV box.
After the components were chosen, we used the power requirements for each component to begin the electrical design. From there, we used the power to determine our wire size, breaker size, and with that we began the schematic diagrams and went to the purchasing factor of each individual electrical component. We have the breakers, the panel, the wire, we use BX armored cable, and all the adapters and connectors for that. Here's the breaker box, and there's 6 20-amp receptacles, and then on the top there's the plug for the chiller, which is a 15-amp. Put this panel on a piece of 1/4-inch aluminum, and then bolted all the receptacles and plugs to that. And from there, we wired all the plugs, then wired all the components on the bench with BX armored cable. And we try to conceal it as best as possible, but it's definitely a great electrical design.
We hope you enjoyed the video. Thank you for joining us.